Today we will be looking at X-ray applications. X-rays are a form of high energy electromagnetic radiation with wavelengths on the atomic scale. Because of their unique ability to penetrate opaque materials and resolve structures at the molecular level, they are indispensable tools across medicine, chemistry, physics, astronomy, and material sciences. What is the role of X-rays in medicine? An X-ray beam is used to create images of the body's interior. The beam is directed through the patient, and a detector records the rays that pass through. Different body structures absorb varying amounts of X-ray photons, creating shadows that form an image. Bones, for example, absorb more photons than soft tissues, resulting in sharper shadows. Air in our lungs shows black. Bones and metals show as white. Fats and muscles show as shades of gray. In medicine, they are indispensable for diagnostic imaging, detecting bone fractures, dental cavities, and cancerous conditions. Techniques like CT scans provide high-resolution cross-sectional slices of the body. Radiation therapies utilize X-rays to treat cancerous tumors, to damage the DNA of cancer cells, and blood disorders like leukemia. The double helix structures, the physical shape of the DNA, diaoxyribonucleic acid molecule, coined by James Watson and Francis Crick in 1953. The structure visually resembles a spiral staircase of a twisted ladder. However, X-ray can cause biochemical changes in living cells and pose health risk. Medical uses of X-ray. In diagnosing lung condition, chest X-rays are widely used to detect infections like pneumonia, tuberculosis, or a collapsed lung. Locating foreign objects. If a child accidentally swallows a coin, battery, or metal object, X-rays can quickly locate the item in their body. Screening for breast cancer. Mammography utilizes low-dose X-rays to detect early-stage breast tumors or microcalcifications. Spotting calcification and stones. X-rays are highly effective at finding dense anomalies such as kidney stones or blockages in blood vessels. Guided medical procedures. Real-time X-ray imaging, known as fluoroscopy, is used to help surgeons place stents, set broken bones, or insert cataracts. Don't fail to share, subscribe to this channel, share with your loved ones. Role of X-rays in physics. Crystal structure analysis. X-rays are used in diffraction experiments to determine the atomic arrangement in solid crystals. This enables the determination of complex molecular structures such as the double helix of DNA. Establishing quantum theory. Compton scattering in 1922 confirmed that X-ray photons behave as particles by colliding with electrons, validating Einstein's theory of quantum light. Material characterization, that is non-destructive testing. X-rays are used in industry and research to examine internal structures, such as detecting defects in castings, welds, and inspecting the internal alignment of components. Atomic structure studies. Characteristics X-ray emission occurs when inner shell electrons are ejected and higher energy electrons fall to fill the vacancy, providing direct insight into the atomic electronic configuration. Nanotechnology and spectroscopy. Techniques like extended X-ray absorption fine structure map the short-range ordering of atoms in amorphous solids. Researchers use high-intensity synchrotron sources to examine the atomic behavior of electronic and superhard materials. Role of X-rays in chemistry. Fluorescence is a phenomenon that occurs when a specimen is irradiated with high-energy X-rays and the innermost electrons are ejected. The resulting gap is filled by the outer shell electrons falling down to fill the generated gap. The energy of the outer shell electron must match the energy of the inner shell electron for it to be able to occupy the inner shell. The excess energy is released in the form of fluorescence. Since each atom in the periodic table releases a characteristic amount of energy, it is possible to form a qualitative and quantitative elemental analysis of any specimen. X-ray crystallography is a method of determining the arrangement of atoms within a crystal. X-rays strikes a crystal and scatter into many different directions. The way the X-rays scatter gives researchers an idea of the structure. Chemical environment studies. X-ray photoelectron spectroscopy uses X-ray photons to eject core electrons from a sample surface, allowing chemists to determine the oxidation state and chemical bombarding environment of atoms. X-rays also help us to calculate for frequency, for spacing, and for theta, space in an electron or in a molecule. Role of X-rays in chemistry. Local structure analysis, extended X-ray absorption, fine structure, and X-ray absorption near X structure are techniques that provide information on the local structure environment, such as bond lengths and coordination numbers, even in non-crystalline amorphous samples. Structural art in chemistry and archaeology. X-rays are used for the non-destructive analysis of artwork, to identify pigments under drawings, and to evaluate structural integrity. X-ray is the most common non-destructive technique used in art conservation and archaeology. X-ray tells you what elements are in a pigment. X-ray tells you how those elements are bonded together. Astronomy and astrophysics. X-ray are absorbed by Earth's atmosphere. Scientists deploy X-ray space telescopes to detect high-energy events in the cosmos. This allows astronomers to study extreme environments, including the accretion disk of black holes, hot gas in galaxy clusters, and neutron stars. In planetary science and archaeology, rovers such as those exploring Mars utilize alpha proton X-ray spectroscopy or spectrometers to determine the elemental composition of rocks and soils. Archaeology provides a non-invasive method to look inside ancient fragile artifacts, mummies, and poetry without risking damage to the objects. Industry and forensic. Engineers use X-rays to inspect the structural integrity of well, jet engines, parts, and metal casting for microscopic cracks or internal defects. For forensic analysis, X-ray fluorescence is used to analyze trace evidence, identify pigments in question documents, and examine ballistic evidence without destroying the sample. Key reasons for X-ray usage. Threat detection. They identify through color coding, organic, inorganic, or metals, dangerous items such as guns, knives, and explosives. Safety and security. They are essential in preventing prohibited items from entering the cabin, such as explosives. It can distinguish liquid and food from metal to ensure aircraft safety. Efficiency. They process high volumes of baggage in seconds. X-rays are used at the airports to quickly and non-intrusively scan passengers' luggage and people for hidden threats like weapons, explosives, and contraband. These scanners detect, differentiate, and color code material by density, identifying organic materials. The picture on this slide portrayed how the authorities managed to recover over 60 cocaine bullets in a woman's stomach through the use of an X-ray scanner. Key potential dangers of X-rays. Cancer risk. Cumulative exposure can slightly raise the risk of developing cancer. X-rays are classified as a carcinogen according to the World Health Organization and the United States government. Tissue effects. High dose, long-term exposure can cause hair loss, skin reddening, or cataracts. Radiation sensitivity. Children are at higher risk and can develop cancer from radiation. Reproductive cells. X-rays can damage reproductive cells if the reproductive organs are in or near the imaging beam. Pregnancy risk. Exposure to the fetus should be avoided, especially in the pelvic area. Mitigating the risk. The technicians are advised to use the lowest dose, called the ALARA principle, ALARA, as low as reasonably achievable. Protection. Shielding layered aprons are used to protect sensitive parts of the body. Limiting tests. X-ray should be taken when necessary for diagnosis. Study questions. 1. What are X-rays? 2. How does the following appear on an X-ray image? Bones, metals, and air in the lungs. 3. List 3 roles of X-rays in each of the following. A. Physics. B. Medicine. C. Chemistry. 4. What are the key reasons for X-ray usage? Don't forget to comment on this video, like, share, and subscribe to this channel. See you in the next class.